All right. So, are we ready? Are you ready, Melissa? Are you ready?
Trying to get a good pencil.
Are you ready? You're ready now, right? You ready? Mentally focused. Ready to go? I am ready. Okay. All right, class.
Yes.
Thank you. All right. So we're gonna go through 5 indefinite integral and method of substitution. So we're gonna go through, and some of the stuff is actually going to be the key to be going through and actually answering a lot of these questions, that the harder, more difficult questions. So once we get to the substitution part, you'll hopefully it will make sense, and I'm not just talking gibberish. All right. So indefinite integral means I'm taking an integral with no bounds. Taking an integral with no bounds. That's basically it. And so if you remember this, if I took a derivative and I had, let's say, 3x plus 2, if I take the derivative of that, I get just 3, right? I get just 3. But now remember, if I get the integral or the antiderivative, it's got to go from the integral back up to here, right? And so this plus 2, because it's now gone, when we took the derivative of it and we take the antiderivative, I need to account that there is some number there. There is some constant that is going to be there. And that's what we refer to as my plus c. I take my antiderivative and then I add c, because when I took the derivative, this constant went away. It became 0. And then it comes back up, and so we just identify it as plus c whenever we do this. Make sense? Better? Hopefully. Okay, here is this. You guys actually have this on your packet of stuff that I gave you guys. I left it on the slide also, but it's also in that packet of like 6 pages. So a lot of these things that you're going to use, okay, these ones are important here. Okay, and derivatives. So some of the derivatives when we actually would get it. So the derivative of cotangent would be negative secant squared. So those things. So if you look at it, it should be the derivative turns into the integral, and back and forth. Okay, so for this first one, A, antiderivative. Antiderivative here, I'm going to add 1, so it's going to be x to the 5th. Then divide by 5, and I can't forget plus c. There we go. That's what the indefinite integral is, because I'm not taking bounds on it. All right, let's look at B. So if I rewrite that, I'm taking the integral of x to the 1/2 dx. I need to add 1, right? So it's going to become
3/2.
So x to the 3/2, and then I have to divide by 3/2. But now, am I going to have? I'm like dividing by a fraction, but can I just multiply by the reciprocal?
Yeah.
So instead of saying divided by 3/2, I can multiply by the reciprocal, and this will become 2/3 plus c. Yes?
Yeah.
Okay. All right, and C, I'm going to do some cleaning up first on C. So this is going to turn into, if I look at it, it's the integral, so on C, it's the integral of, what is, if I rewrite that, cosine squared could be rewritten as sine over cosine, right? Yes?
Yeah.
Times 1 over cosine, right?
Yes.
What is sine over cosine?
Tangent.
Tangent, very good. And what is 1 over cosine?
Was it cosecant or secant?
Secant. That one's secant. So if I were to just rewrite this by rearranging, I'm taking the integral of secant tangent. So secant tangent, let's look up at that last slide. Okay, secant tangent, which one is secant tangent?
First one underlined.
There we go, so it's this one right here. So by rewriting it, by going through and rewriting it, I actually get one of these out of it, right? Hopefully, it makes my life easier. So the integral of secant tangent is just going to be secant x. Or if you guys remember the derivative, so the derivative of secant is secant tangent. So going back and forth on that one. So that's going to give me my secant x plus c. Yes, no, maybe? Okay, good. Use properties of indefinite integrals. Since the definite integral and the indefinite integral are closely related, properties of indefinite integrals are very similar to those of definite integrals. Derivatives of an indefinite integral. So, what it says here is that if I take the derivative of the integral, I should get right here. So, if you take a look, it is actually times, so that's the property. So we're multiplying it out and we should get here. So we're breaking it up into the separate parts. So the derivative of the integral is going to give me same thing. Just like this one right here. Derivative of the integral is going to give me the same thing. Should have a space in between those two so you can see the difference. So indefinite integrals, sum of two functions. So it's the same thing, just break it up into two separate functions. And when we do this, you are going to have a plus c. So if you take this one right here and you get this answer, I would get a plus c for this one. And over here, I also get a plus c, right? But since they're both constants together and I separate them, I'm just going to say that they're individually 1c. Because if that one's 2, that one's 5, I would just say plus c, which is 7, with both of them together. So you don't, if you break it up like this, you don't have to put plus c. It's identified with just one of the plus c's. All right, so for here, what we can do, if there is a common factor right here, which is our k, which is some multiple, some constant multiple, so it's like 5 times the integral, we could just take 5 out and just multiply it at the end. We can multiply it times my answer at the end. So what that is we're going to do some problems later on where you're going to have a pi in the question or in the problem. You could factor that out to the beginning, so it's less to worry about because pi is a number, it is a constant, and I can factor it in front of my integral so I don't actually have to deal with it when I'm integrating. All right, let's see what we get here. All right, try this one, please. So I'm going to take a 2 in front of this one, and I'm going to call this one x to 1/3 dx plus 5 integral of x to the -1 dx so I can integrate the first one pretty easy. That one's going to give me 2, right, times, that's going to give me x to the 4/3, very good, x to the 4/3, and then times 3/4. 3/4. Remember, because we're dividing by 4/3, we can just multiply by the reciprocal. And then again, there is my plus c here,
Is that AX?
dx. That's a dx, I'm
Oh,
sorry.
that's a D, okay.
And my next one is going to be plus 5. Now, this one right here, what is that going to do? That was something special. ln. So I'm going to have ln, right? That's going to be 5 times ln of. There was something special about this one.
1.
I know ln's on here somewhere.
ln X. Plus C.
Absolute value. Okay, we have to state that, especially on the indefinite integrals, because we have variables here. On a definite integral with bounds, I'm plugging in numbers, and I would make sure that I would do the absolute value from there. But since this is still a variable, I need to state that that is the absolute value. Oh, there we are. So absolute value x plus c. And now I have 2 different constants here, right? And since I have a factor of 2 times that, it's like 2 times the constant is still a constant, isn't it? And just like 5 times this constant is still going to be a constant. And when I add a constant and a constant, I should end up with a constant, right?
Yeah.
So I'm still going to end up with a constant, and this is what I was talking about. I have 2 separate ones right here, and so when I put them all together, I'm only going to have 1 constant. I'm not going to have 2 separate constants here. So let's go ahead and do my multiplication. So this is going to give me 3x to the 4th over 2. This is going to give me plus 5 ln absolute value x, and then plus my constant of c. Yes, no, maybe? Possibly, on occasion. Don't worry about this one, because I haven't actually mentioned about how to do that one yet. We do this first one here. That would give me, just go ahead and do my integration right there. So isn't that 5 to the x to the -5, right?
Mm-hmm.
And so I still need to add 1, right?
You still need
I still need to add 1. So that would make it x to the
-4.
x to -4. So this is going to give me 12 x to the negative 4, and then I'm also doing what?
Divide.
I'm not, I put negative in the wrong spot, sorry. X to the 4, right?
Okay.
Okay, x to the 4, and then, actually, let me just move this up, so make it a little bit easier. So that's 12 x to the negative 4, and I have to also divide by the same thing, right? Which is negative 4. So instead of doing the mental math on this one, make it easier to just show that it's the negative plus. This is going to be x to the negative 1/2. So if I take the integration of that, that's going to add 1, so it's going to be
1/2.
1/2. It's positive 1/2, right? So that's going to be a positive 1/2. So it's x to the positive 1/2. And then I'm going to divide by 1/2, or multiply by the reciprocal, which is going to be 2, just 2. So it's going to give me a 2 right there. And don't forget my plus c. Go ahead and do the math over here. This is going to give me a negative 3 x to the negative 4 plus 2 x to 1/2 plus c, or it could be rewritten, because quite often they, like when you're doing it on the homework or on the AP exam, they don't want negative exponents. So you would just move that back down. Negative 3 x to the positive 4 plus 2 x to the 1/2 plus c. Yes, no, maybe?
Yeah.
All right. We have not addressed those ones yet, but let's take a look at it here. Indefinite integral using substitution. And I will show how to do this here, because I left all the steps right here, so it's easier when you guys are doing this to come back to this and look specifically at this. So I'm going to start with this. So x squared plus 5 to the third, 2x dx. Now, item by item on this, hopefully this will make sense here in a moment. Right now it looks kind of crazy, doesn't it? Is that a product and a chain? Yeah, it is a product and a chain. And so if I was to take the derivative and I see that, and that's when the key should come in, oh, I'm going to try and substitute that, because if I have products and chains and all that, I'm going to have to substitute to actually make that work. So what I'm going to do is, I'm going to say my u is going to be this. So u is going to be x squared plus 5. And if I take the derivative of this, and this is how this works out. So if I take the derivative, this turns into a du is going to be what? 2x. So du is 2x. And I took the derivative in terms of x. So because this is kind of like that implicit differentiation. Remember when we took the derivative of a y? What did I need to add if it was the derivative of something else? Yeah, dy dx, right? So in this case right here, took a derivative, right? And so this is going to be a du dx because I'm taking the derivative of u and taking the derivative of x. So that's where that comes from. Yeah? Okay, so now this is going to replace all of this right here. So it's going to replace that right there. And my u is going to replace this right here. So rewriting it, I'm going to have the integral u is going to replace all that. So it's u to the third power times du because I'm replacing all of this with du now. Because using u substitution, I now had to change it from a dx to a du because I'm now taking the integration in terms of, say u. Yeah, I'm going to take the derivative, integration in terms of the u. So if there's any other x's left over, I would have to rewrite this thing right here. I would have to rewrite this using substitution to try and get me an x by itself. So let's integrate this. This is going to give me u to the fourth power over 4, right? Plus c. Now, is that my answer? Say no. No, that's my u, right? Okay. Do I know what u is? Yes, I do.
Oh, yeah.
We know what u is. So we could say that this is going to be x squared plus 5 to the fourth over 4 plus c. Okay, yeah, that one's 6. So, in all of this wording and all this definitions of everything, they got the same thing. So, hopefully my explanation and walking through it is a little bit clearer.
I just don't know where to use mine.
Huh? You don't know where what went? When I take the integration, remember the integration is the undoing of this. So integration is the opposite of derivative. It says du is the delta, it's the change in.
Okay.
So remember, when we did the implicit differentiation, we'd have like a dy dx
Yeah.
or just a ddx. So the dx is referring to that value.
Yeah.
Here, try this one now. So the first one here, try the first one. finish working on it, I'm gonna start mine over here. Alright, is that 3 kind of confusing you there? Because the 3 is not replacing directly for something. So what I did is, so when I took the derivative, I only had to replace for my dx in this one. Because on my previous problem, I actually had something specifically that worked out. So my derivative was exactly the same as with my dx. So I had those. But now all I need to do is just get my dx by itself, because I have to change this from a dx into a du. So now this is 1/3 of my du. That's why I put a 1/3 out front. Let's take my integration. So the integration of sine is going to give me
Negative cosine?
negative cosine. Very good. So it's 1/3, negative 1/3 cosine of u plus c. And what do I do with that u?
Subdivision.
Just put it back in. So I get negative 1/3 cosine of 3x plus 2 plus c. Is it almost time?
I don't know, because I'm not used to
No,
Mondays
yeah,
anymore.
I know, it's Monday, it's weird, because I thought we were going until at least 40 today. I thought it was still regular classes, right? Okay.
It's late start, and I'm like, oh my god.
Alright, let's try B now. So each one, I actually really like these ones because all of these are puzzles. Everything is a puzzle.
I can't do puzzles. It's like the 500 pieces, I can't find my edges.
So again, look at it. It is a chain, right? It's a product chain. So especially any of them that are chains are the ones that you're going to want to use up. All right, thing 1 and thing 2. Tomorrow morning, 8 a.m., we're doing our practice AP test in here. Okay? So I know it's Aspire testing.
Yeah.
Yeah, so, but yeah. So you're going to come in with all of these sneaky freshmen. But you're going to just come in here. So you don't have to, out there. Alright, for my u's, I get x squared plus 1, and I come up with 2x dx, and since this problem over here doesn't have a 2, so what I'm going to do is I'm going to divide both sides, so it's going to be 1/2 du. So, but I can still replace my x dx. So this x and this dx are being replaced when I put this in. So I'm now going to have the integration 1/2, because I'm pulling the 1/2 out, integration of u to the 1/2, and then it's going to be du, because that du over 2 is my 1/2 that I put out front. Do my integration, 1/2, and then this is going to give me u to the 3/2, and then I divide by 3/2, which gives me 2/3 plus c. Put that back in, so it's going to be 2, oh, not 2, because the 2's cancel, u 3 over 2 over 3 plus c. And then sub it back in, I get x squared plus 1 to the 3 over 2 over 3 plus c. Last one, e to the x over epsilon. This one gets complicated, doesn't it? What makes this part complicated?
Quotient.
The quotient, right? What makes it a chain? The e to the
Square root of x.
yeah, square root of x. Okay, so if that's the chain, that's where I want to, that's my key. That's what I want to look at to make my u. So if I say u is, let's say, x to the 1/2, then I could say du is going to be x to the negative 1/2, right?
Yeah.
Over 2 dx.
And you derivative
Yes,
of
that's the derivative there. Now, I'm going to rewrite this, and hopefully this will actually come up clear now. So it's du is equal to 1 over 2 x to the 1/2 dx. Now, can you see it from here? What do I do now with this? Multiply by 2, very good. So if I multiply by 2, I'm going to have a 2 out here. But isn't this x to the 1/2 on the bottom the same as this x to the 1/2 on bottom there?
yeah.
So that's key right there, that it's going to fit together like that. So I'm going to replace this and this together with 2 du.
So it'd be like
E to the,
square root of x.
no. What is,
Oh.
it's going to be e to the u. So it's integration e to the u, because I substituted this also, right?
Yeah.
That was part of it, all this right here with my dx. So both of those go away, and I'm left with just 2 du. again, a puzzle how all these fit together. Now integrate. What's the derivative of e to the x?
E to the x.
So what's the integration of e to the x? E to the x, right? So e to the x, I know, right? So it's going to be 2 e to the u plus c.
Oh, you combine them.
Combine what?
The 2 and the e.
Yeah, the 2, because when I take the integration, it's 2 times that. And then put that u back. So it's 2 e to the
Well, square root of 2, square root of x.
square root of x, if we want to put it back looking like that, plus c. Crazy, right?
A little.
A little bit.
Was it?
All right, so this is what I'm gonna do. So we're gonna leave off here today. I'm not gonna assign this homework yet. I'm not gonna assign the homework. What I am gonna do is tomorrow you guys are gonna take that AP practice test. So work on that. If you guys still got the books, work on the books. You got that packet that I printed off for you, use the packet. So make sure everyone likes, share, and subscribe.